Recording. Yeah, it has been started. So before I go and discuss and ask you to implement the white box, so let us understand the theory behind the white box, the testing, and then only we move ahead to implement it. Right? So when you take care about the white box, so naturally when we were discussing about the black box testing, we always had a discussion about okay the tester is not at all aware of the architecture of the entire flow, architecture of the entire functionality, or the way the data is getting validated. It is only going to say okay whether this particular test is pass or fail, and basically it is going to it is going to dependent on largely on the data. It is never going to check whether the logic is valid or not. It is never going to check whether how many times the iterations are happening, because testing is a time consuming process. So sometimes the testing may actually hamper the performance of the entire product life cycle as well, because it is a time consuming process. So you need to check the way we have discussed in the black box, okay, the how many the partitions are going to be there, into which different kind of data set may exist. So this is the thing what you need to understand, that based on the partitioning and based on the data set, those many of test cases we need to take care about. Am I audible to you clearly?
Yes, ma'am.
Yeah. Now, so the concept of white box, so white box, as the name says, that okay, you can see everything. So when you say that you can see everything, that means you are aware of the architecture of that particular software, how exactly that software looks like. You are aware of the loopholes, you are aware of the logic of that particular functionality, what you have built, and based on that particular thing you can see okay whether any of the runtime errors are occurring, or whether any of the errors are occurring for which a particular data set is missing. So with that particular sense, the white box testing which is executed by the software developer, because he is aware of the architecture in the detailed manner, so in that case the white box testing is going to be executed. So when you say that what exactly the white box testing is, so you can take care about the white box testing is a kind of testing you can say where which is actually going to evaluate the code. So let me open my Word document. Just hold on. Yeah, so let me share my Word document with you. Yeah, are you able to see the Word document? All the students?
Yes, ma'am.
Yeah. So when you say the white box testing, it is nothing but the tester, which is no one but the software developer, is aware of the architecture as well as coding flow of the functionality. So this is the thing what you need to understand, that okay that I'm aware of that how exactly the data is going to move from one particular place to other, or data is going to flow from one particular place to other. So this particular thing I'm aware of to tackle that okay if this is going to be if this is going to be a situation, how can I handle this error which is coming. So most of the time whenever the white box testers are going to work on, so whenever the product is going to release, so some of the white box tester, or you can say the software developers, they are themselves are going to be on the customer support, because the people who are sitting to answer the customer calls, they are not at all aware of what is the exact thing which is going in the background. Are you getting what I'm trying to say? All the students, they are not at all aware of that what are the things which are going under the, or which are behind the background, how are the things, what is the architecture. So naturally the query is getting promoted or propagated to the you can say to the software developer, and that particular software developer is able to answer that, okay, what is the reason behind this particular error and how I can solve it. So this is what the white box testing is, and you do require a particular responsible person to take care about the test case. Are you getting now, all the participants? So generally, when you say the white box testing, it is going to cover, the first is going to be, let's say, uh, code coverage. Second is going to be the segment coverage. See how exactly the code is first there, then it is being dropped down to the segment. Segment is being divided into a one particular branch. So condition branch is supposed to be executed. You can say branch coverage, or after that you can talk about the compound coverage. Are you getting all the participants what I am trying to tell you? Now, compound coverage, that means, or you can say here, compound condition coverage, right? So when you take care about the code coverage, so basically, naturally, we are as a software developer as well as a white box tester. I'm aware of, okay, what is the architecture of this particular code and how exactly the things are going to move. That's what each and every participant is supposed to take care about, because many of the participants, they need to go with the white box testing because black box testing is not at all possible into their dissertation project, isn't it? Now, when you say the segment coverage, so or the segment code, or you can say segment code coverage, you can say that every code segment is going to be executed. So this is the code coverage, what you need to have. The next thing is going to have the branch coverage, where the, the code or conditional branch is getting executed, right? Now the compound condition coverage, you can say that where many conditions are combined using and or will check each condition execution. Fine. Now I'm done. Okay, I'm really happy. Okay, I'm covered each segment as well. Each branch has me conditional branch, and the compound condition I'm going to get. Now, but I am really not aware of that for which particular path my code is executing. Okay, this is a functionality of the registration, for example. So I'm not aware of how my code is getting executed during the during the test case generation for, or during the execution of the test case for my registration process or for my login process. So in that particular case, that basic path which is required, okay, the data is going to flow from one place to other place, then to the other place. So every independent path is going to be checked. So that is known as the basic path testing, which is going to say that every individual path is going to check to understand the data flow while case execution. Are you with me, all the participants? Are you able to
Yes,
understand
ma'am.
what we are discussing?
Yes, ma'am.
See how exactly the flow is, and after that you are going to have the data flow. That means you are going to take care about one particular input to a variable until the final output after the computation. What is the path where the data is getting transmitted, where the data is getting flowed, how, which kind of computations are getting done. So this is going to go with the data flow testing, which covers the flow from input till the final output. You getting what I'm trying to say? Now, the next thing is what you need to take care about, the looping construct. When I say for loop, when I say while loop, when I say how exactly the do while loop is also going to be there. So some of the time, what is going to happen if I say, let's say for x equals to 2 to 10 or 2 to 15 or 1 to 15 or 1 to n, where n could be from the 10 to 20. So in that case, if you take care about the single loop, which condition is getting executed, if you go for the concatenated loop, or if you go for the what you can say the nested loops. So in that particular sense, how exactly each and every loop construct is executed. And please make sure, uh, uh, have you discussed about the data structures and algorithm? Have you studied? Have you gone through? Hello, all the participants. Have you
Yes,
gone through
ma'am.
the data structure and algorithm?
Yes, ma'am.
Okay, so you must have studied there the time as well as the space complexity. Hello.
Yes, ma'am.
So can you tell me what is the objective of having the time, or what is the objective to discuss about the time as well as the space complexity?
Ma'am, as in like the time required should be the least, like the minimum, and the space also consumed
So
by.
can you just let me know with the example?
Ma'am, regarding a code, like we are talking in regards of a code, right?
Mm-hmm.
So,
Or
ma'am,
any algorithm. Do not bother about the Java or Python or anything, any algorithm.
in if we consider sorting practices, then we opt assertion sorts because it
Mm-hmm.
takes less amount of time to execute, or other than that, regression practices are
Mm-hmm.
avoided and iterations are adopted to save the time.
Okay, so this is a fundamental thing. Have you gone through some of the problems which cannot be or which are quite difficult to go through with the data structures?
Ma'am, I guess so. I'm not sure.
Okay, did you solve any specific real-time algorithm by using the data structure and algorithm concept?
No, ma'am.
Okay. Have you studied the shortest jump first algorithm?
Yes, ma'am.
What is the complexity if someone asks you what could be the complexity of that algorithm? Yeah, anyone? It's not only you, Shruti. Anyone? Fine, forget about the shortest jump first. Have you gone through the traveling salesman problem? Come on, all the participants.
Ma'am, if we talk about shortest job first, so are we like talking about time complexity which we used to denote by logs and everything?
Mm-hmm. Fine. So now, if I'm going to have multiple loops, let's say so, all the participants, are you aware of that multiple loops are being discouraged to use in the programming? Yes or no? Are you aware of that fact?
Yes,
Hello?
ma'am.
No.
Yes,
Why is
ma'am.
that so?
Yes, ma'am.
It
Why do you
increases the
think
time
so that
complexity.
loops are? Yes?
It increases the time complexity of the program.
Okay, how does it increase? Can you tell me?
Ma'am, I know
Uh,
that go-to statements are not used,
Yeah?
which are like different from loops, I think. I mean, they're like unconditional loops.
Uh huh.
Time
Yeah.
complexity becomes n square.
Yeah, so why, what could be the reason why the loops are being discouraged to use? It's fine that, okay, it is going to increase the
Ma'am,
time
because
for the
basically,
execution, but
I think it's because of when we learned the microprocessor, that is the 8085 or any processor, take for
uh-huh.
example, I mean, there is something called branch prediction in the processors where the
Mm-hmm.
processors try to predict what, like if there's a jump a statement, they try to predict what's the next actually no, when there's a jump statement that's called, it has to jump several assembly language statements and then go to the statements to which it's supposed to jump.
Mm-hmm.
And like if it keeps on jumping, then the problem exists where the program counter, that's PC, it keeps
Mm-hmm.
incrementing to the next iteration, but
Mm-hmm.
that's not the next statement of code that it's supposed to execute. It has to execute like the one it's supposed to jump to. And
Mm-hmm.
because of that, we have something known as branch prediction, which predicts. So to help the branch predictions, that's why we need to reduce the amount of jump calls that we do.
Fine,
That's
but the
why.
loop is not going to include that much of jump,
Okay.
isn't it?
But at
So,
least like
Ma'am,
go-to
if I
statements might include that much, because go-to is
yeah,
like
Goto is
unconditional.
going to include, Goto is going to include, or any of the
ma'am,
function call from your program is going to include those things. Yeah, who is it?
Ma'am, this is Kshitij.
Yeah, Kshitish.
So, ma'am, in the general concept of time complexity is this that a program runs by a line of code. So,
Mm-hmm.
the more number of lines, thereby the more time it is taken.
Mm-hmm.
So, the concept with loop is that it repeats that number of lines. So,
Mm-hmm.
the more the number of lines, the more times the n square, the power of the square will increase.
Mm-hmm.
So, in the concept of loop is that if there is a nested loop, so it's n cube, big O of n.
Mm-hmm.
If it's so, the more the loops
Mm-hmm.
and more nested loops there are, the more time it will take because it will repeat those lines more consistently and more times as compared to a normal run through of code.
Mm-hmm.
if the task can be done within a single like run without a loop, it is much
Mm-hmm.
more efficient and much more better, as it takes less lines of code to like be executed, and
Mm-hmm.
it also solves the problem. So basically, less time consumption.
Fine, fine. But don't you think so? Whenever loop creates any of the temporary data, loop is going to increase the computation time as well for the CPU. It is going to increase the CPU cycle, isn't it? Hello? The process
Hello,
is going to be more IO, more CPU bound than the IO bound.
ma'am. Can you repeat your question? I got disconnected for some time.
When you go to the multiple loops, the process is going to be more CPU bound than the IO bound.
Okay.
And
Yes.
now
Yes.
try to understand this thing. Loop is always going to have the temporary computation values as an output till the final output is going to be computed, isn't it?
You mean that it's going to hold on to the CPU resources till the
Exactly. I
point
do
of
require some space to hold the values. Are you getting? So
yes,
that
ma'am,
is the
agreed.
major reason. The space and the time complexity is always going to be considered when you take care about the loops. The only reason behind that is because it is going to occupy the main memory, as well as it is going to have more and more computations with respect to the CPU. Are you getting
Ma'am,
what I'm trying to say?
yes, ma'am. The more the number of lines it has to calculate, or the more times it has to execute, the more RAM and the more resources it will occupy.
Exactly. So for that, so now if the software developer has created many loops in that case, many loops in the program, so naturally the things are going to be quite difficult to address with respect to the performance, because whenever you are having the loop, in that case you need to address the situation about how exactly the memory is going to be managed, how exactly the memory allocation is going to be managed to keep these temporary values, which is
Yes,
being
ma'am. Yes.
computed by the loops, isn't it? So loop testing is actually, it's going to take care about the, or it's going, we need to discuss a lot, or you must have discussed a lot while going through the space and the time complexity for the loop. Have you taken the loops as a case study?
Uh, Not really, ma'am. It's just like in certain concepts that I read that the more amount of objects that are
See,
present.
again, all the participants, again, I would like to tell you something. Concept without the implementation is of no use. Try to understand this thing. Okay, so right now, if you get the time, or if you get the idea, try to implement, try to see what is the time complexity if that particular loop is going to run for 20 times or for 50 times, and what could be the space complexity, what are the values the loop is going to create, and what are the test cases are going, those are going to be executed based on those values. There could be some of the values for which you have just missed the test case. Are you getting my point? And if you have just missed the test case, so we cannot do anything. Let me tell you one example. On Saturday, I believe, yeah, on Saturday, I was, handling one particular, I'm not aware of, have you worked with the Linux operating system? And if you have seen the top process, in the top process, one particular process is going to be have the S and then D and then R. S is for sleeping, R is for running, and one state is also known as a RT. RT stands for the real time process. And real time process, that means it is continuously running to check the management of all the resources within your Linux operating system. And when this process is being created, so naturally this process is going to have the higher priority because it has always have to check the resource management. So in that particular case, so how exactly this process is being tested? Every time, whenever this process is going to run, every time it has to go through the user managed processes who are responsible to have different kind of resources with it. Isn't it? It is always going to check whether some particular process is running or some particular process is terminated so that the resources can be released. So there is also a test case to see this particular process whether it is able to release all the, so this process is running inside the loop. More and more loops you are going to have, the performance is going to be that much slowed down. So generally we do not keep the loop if the data for which the loop is going to be is quite static. Say I would like to check only for the data from the range 50 to let's say 60. Only the 10 values I need to check. So I'm going to give the short loop only 50 to 60. Are you aware of that on to one particular time, the for loop is going to perform better than the do while loop? All the participants, are you aware of that? Hello?
While loop, maybe because it's checking the condition at the first, and then every time
No, no,
it's
no,
keeping on checking
no,
the
no, no,
condition.
no, no. This is a normal difference what you are saying. But try to understand when you say in the for loop, the end value is being predicted and it is being saved. It is never going to be computed. Are you getting my point? The end value, the loops is the whatever the resources are required for that particular loop is already reserved. In the while loop, the end value we do not know. Are you getting my point? And as well as the do while loop as well, because the condition, it is going to be there till the condition is going to meet. But that condition has to be computed. Are you getting my point, all the participants? That
Yes, ma'am.
condition has to be computed, and if the computation doesn't happen, then we are gone. There is a question, Nirmit. Nirmit, yeah, I did not get your question. Can you tell me what was your question? How exactly? Are you there, Nirmit? It's clear? Yeah, fine. So this is the reason. So if the values are not getting changed, or sometimes what is happening, I do not know whether you have done this thing or not, but let me tell you. If I need to reduce the chances of loops or loop construct, what I can do is I will see the performance. Calling the function for 10 times and having the loop for those 10 times, which one will perform better? Are you getting all the participants what I'm saying? I am having the range from 50 to 60. Either I can go for 50 to 60, put the values into the loop starting I equals to 50 and I plus plus until the 60. Or what I can do, I will call the function 10 times from starting from the value 50 to 60. Are you getting all the participants? So how exactly the space and the time complexity is calculated, and that's how the loop is going to be written. But when the loop is going to be written, so whenever we give the less than and the greater than sign, now try to focus on what I'm saying. Whenever we give the less than and greater than sign, I will just go with those values. If I'm going to give the less greater values between 50 to 60, so it will cover the decimal the integer as well as the floating value. But when I go for the function call, the values could be from 50, then 51, then 52. It may not cover the values 50.11. Are you getting my point? So you need to understand that which of the construct is covering more values. Which of the loop construct is covering more values. Suppose if I go for 1 to 10, so I'm going to say okay, 1, 2, 3, 4, 5, 6. I'm not going to see here 1.25, 1.5, 1.75, isn't it? But when I'm going to use the while, and when I say less than equals to this, so it is going to cover all the values. Yes or no? All the participants. Are you with me? Are you getting what I'm discussing? We are discussing when to take care about the loop and when I need to have the function call for the values. Satvik, Nirmit, Himesh, Del, are you with me? Kshitij, Akansha.
Yes, ma'am.
So when I'm going to say the function call, so I need to put the exact value over there. Or if I'm using the for loop is going to have the exact value. But when I'm going to take, because range it is going to define, but when I'm going to use the less than equals to or greater than equals to sign, it may cover the floating point as well. So you need to understand that if your data set is going to take care about these kind of values, so you need to address that which particular loop you need to use, or instead of loop, can you use just the function call? Are you with me? Shall we proceed right now? Any question?
Yes, ma'am.
Okay. So you need to understand two things right now here, that whenever we go with the white box testing, so let me open the document again and let me say the white box testing or WBT. First of all, you need to understand the functionality or the architecture of the software, how it is moving. Okay. So against data. The second is create the respective test case, you can say, and on the execution. Right? So you are going to go inside of that particular program, and according to that you are going to plan the execution. So generally whenever you are going to have the white box testing, your unit testing or integrate or whatever the non-functional and the functional testing, whatever we have discussed, those are going to be the part of WBT, integration testing. Because the software developer is going to take care about those things, that's why we go like this. Fine. Now, so how exactly what are the different kind of techniques the white box testing is going to move on? So first is you need to understand, as we have already discussed, is the statement coverage. Then you need to take care about the branch coverage, and then you need to take care about the path coverage. Are you getting what I'm trying to say? All the participants?
Can you just explain what do you mean by branch coverage?
Yeah. So first, let me tell you what exactly the statement coverage is. That when that particular statement is getting compiled, then it is going to be executed, and then it is going to, perform the action. So this is a kind of say that each and every statement of your program is being covered based on your test code. Suppose you are writing A equals to B plus C. So you need to make sure that okay, A equals to B plus C is being executed by the test code. Are you getting my point? It should not happen, okay, this is obvious, A equals to A plus B, that means, okay, 2 plus 3 equals to 5 if I'm going to get. So this is obvious, so but it should not happen that, okay, just because of the obvious, you are just going to, skip that particular statement. So this is the thing what you need to understand. The second is a branch. The branch coverage is getting generally or it is of as the name says, obviously it is going to take care about the conditional branch. So conditional branch, when you go with the if statement, so it is going to return you the true or false, isn't it? So if the statement is returning the true, so one particular branch is going to be validated against one data. But I need to make sure that condition as well when the statement is going to return false. I'm not going to say, okay, that for this kind of data, the statement is returning the true. I need to give such kind of data as well. For this, the branch is going to return false. Are you getting my thing? I believe, Satvik, now I'm clear to you. So
I
you
didn't
need,
understand what do you mean by branch coverage and why would it?
okay. So when you say the branch, so conditional branch we generally cover over here. So let me write it out. Conditional branch. Now what is a conditional branch?
It's
Here,
like an if and else statement, yeah?
yeah, if and else. Okay. So now this particular thing is going to return, suppose if is returning the true. Fine. So we always call this as a true or false. So what I'm going to have, I do have the data set which is always going to return true. So naturally the else part is never going to be executed, isn't it? But now I need to figure out that data as well, which is going to go there into the else part. That means I'm going to execute this branch as well as this branch as well by means of my test case. Are you getting, Satvik, what I'm saying? Hello?
Kind of, not fully.
No. Okay. When you say kind of, where is the confusion? Can you please let me know? See, I do have a one particular data set. Suppose I am checking for the integers. So I'm going to say, okay, if this particular integer, if this particular condition is true, the integer is going to be returned. So always the data is going to coming by means of for this particular condition to be true. I am never going to have the data for which the else condition is going to be executed. Are you getting my point? And if no else condition is going to be executed, then why I am putting this else condition into my program? Are you getting, Satvik?
Yes, ma'am, I have put it.
Yeah, so this is a branch of the false branch, you can say conditional branch. And into that, I must make sure that there must be some data which is going to execute this branch as well.
Yes, ma'am.
Fine. So whatever you have written into your program, each and everything or each and every statement is supposed to be executed. Then and then only the things are going to work, otherwise not. Fine. Now, the next thing what you need to understand is a path coverage. So, which is going to tell that all path of the program are traversed and check at least once. Are you getting what I'm trying to tell you? At least once. Now, when you see the path coverage is naturally is going to be a superset of branch as well as the statement coverage. Don't you think so? Yes or no? Hello?
Yes,
Are
ma'am.
you there? Yes or no?
Yes,
So
ma'am.
path coverage is going to be a superset of your statement coverage as well as the branch coverage. Every path, so what it is going to cover? Every path of your programming logic is being covered by your test case. And when it is going to cover? When you start executing with respect to one particular data. Do you remember that what we have discussed? Verification is with respect to the process, but validation is with respect to the data. So the process is getting validated against the data, and that's what you are going to have the white box testing. So have you debugged any of the program? Have you debugged any of the program?
Yes,
So
ma'am.
don't you think debug is nothing but a kind of path coverage itself? That which particular path for this data your program is executing. As simple as that. So now simple, if for example, if I'm going to create a flow, a flow chart to understand whether a particular condition is equals to this or not. So I'm going to check, okay, if the condition is getting met or if the condition is true and as well as if the condition is false. So I need to take care about every condition. I need to take care about the nested condition. I need to see how exactly the things are going to move on. So, for example, if I'm going to say, uh, let me open up the Naresh Chauhan book. Yeah. Let me start sharing again. Are you able to see the book at my end? Page number, you need to go to the 144. Are you able to see all the participants? Go to the 144 and there they are mentioning the statement coverage. All the statement of a one particular functionality have to be executed at least once. And if the statement is not executed, so why you have written that statement into your program? That means there is a bug which you need to address. So this is a simple C program. Is my book visible to all of you? All the participants? Is my book visible to all of you? Yeah. So now you can see that, okay, you are scanning the X and Y. X equals is not equal to Y. X is greater than Y here. It is not. So what it is, while X is not equal to Y. That means this condition is always going, the loop is always going to be executed till X is not equal to Y. But any of this statement is not going to execute when X equals to Y. Are you getting my point? All the participants. Any of the statement is not going to execute when X equals to Y. Now, when X equals to Y, then what should I do? Isn't it? Now, if I am going to generate the test case X equals to Y, where this test case is going to be executed? All the participants. Nowhere. Yes or no? Hello? Am I audible to you, all the participants?
Yes, ma'am. Yes, ma'am.
Are you getting what I'm saying? When you say, if you see the example on the page 144, at your end as well, you can open up the book. And what they are trying to say, while x is not equal to y, then only you apply these many of or execute these many of the conditional statement. But what if x equals to y? There is no statement for x equals to y. Are you getting my point? So even if I generate the test case for x equals to y, because test case 1 is going to skip the while loop and all loop statements. Nothing. I'm just going to execute the printf x equals to whatever the x value of x and whatever the value of y. Nowhere I check this particular thing into the code that if x equals to y, so what I'm supposed to do. Are you getting my point? All the participants, are you getting my point?
Ma'am.
This printf statement is irrespective of whatever the value of x and y, whether they are equal or not equal, the print statement is going to work according to that. But what I'm supposed to do? Into this particular condition, they said, okay, if x is not equal to y, while x is not equal to y, but they have checked if x is y, so this is the branch condition, if it is returning true, and if x is less than y, then it is returning, this particular condition is going to be true. So greater than is being tested, less than is being tested, fine, or less than equals to is being tested, you can say. But where is the equals to tested? And if the equals to is being tested, am I just supposed to print the value into the equal to condition? What I'm supposed to do? Isn't it? I'm supposed to take some action when the condition is going to be true. Yes or no? My dear students, bolo.
Yes, ma'am.
So x equals to y, this condition, this test case can be skipped. Two more test cases are there where x is greater than y and x is less than y. I'm fine with it. So statement is getting covered. Every statement is getting covered. If and only if x is not equals to y. But when x is equals to y, that particular statement, that the functionality is not being tested. What I am supposed to do? Are you with me? So into your dissertation project as well, these kind of things are always going to be there to understand that what I am supposed to do if it is not being tested. So you need to address that particular functionality. If this condition is true, then what you are supposed to do? So whatever the condition the program is or whatever the logic the program is showing right now on to page 144, it is not covering when x equals to y. Are you getting my point, all the participants?
Yes,
So
ma'am.
whatever the test cases they have designed with the, with the statement coverage, it is fine with the statement coverage. Every statement is getting covered if and only if x is not equal to y. Now, If you go into the next state, what is this trying to say? Decision or the branch coverage. Now, so we are having 5 more minutes into our hand. Just go through decision and branch coverage. Do not go through the multiple condition coverage. And can you let me know what it is trying to tell you? Just now we have discussed. Can anyone tell me what it is supposed to do? Decision and branch coverage. I hope my screen is visible to all of you. Or you can go to the page 145.
On page 145, it talks about cyclomatic complexity.
No, 145 at my end. It is a decision or branch coverage, chapter number 5. Dynamic testing, whiteboard
Yeah,
testing.
chapter number 5, page 145, dynamic testing, white box testing techniques. It's
Mm-hmm.
B. B is cyclomatic,
No,
cyclomatic
5.2. Can you
complexity.
go to the 5.2?
5.2. Okay, wait.
There the statement coverage is there, and then there is a decision or branch coverage is there.
Okay, yeah, I saw that. Thank you.
Yeah, anyone?
They say that the branch prediction, each decision takes at least once.
So that's what every statement is supposed to be executed, and within every statement, each condition is going to be executed. That's what we have discussed as well. That you need to keep the data in that fashion that it is going to force the execution of every condition into the program. Okay? Fine? So we'll stop here right now, and again let me download the attendance.
It says here that the black box testing can only be done after the application is completely finished.
Exactly, yes. The white box testing has to be done before, because the coding has to perform first before the black box testing. Isn't it? So that's why the fundamentals of the black box testing is really absolute right now. No one is using, and starting in the DevOps as well, the things are really different. We are starting with the agile as well. We are not bothered about how exactly the black box is moving. We are just bothered about our story as well as our execution. Fine. I
Okay.
hope it is clear now. Okay, so I will stop the recording right now, and